Hello friends, so here is another question. So it is given that a ball is thrown vertically upwards with an initial velocity of 29.4 meters per second, and we have to describe the motion of the ball. That is, right from the moment it is thrown upwards, it goes against gravity, then finally it comes to rest at certain point, and then finally it begins its journey downwards with gravity. So we have to describe the whole thing. Okay, so let us draw a diagram. So here we have a ball which is thrown vertically upwards with an initial velocity of 29.4 meters per second. Okay, so here in this case, when the ball is thrown against gravity, we know that gravity is acting downwards, so it will be opposing the motion. The velocity and acceleration, they're in the opposite direction. I've always told you, I've discussed this in the motion under gravity and sign convention thing, that when velocity and acceleration, they are in the same direction, acceleration will be taken as positive because it is supporting the motion. It will accelerate it. But when they are in the opposite direction, acceleration will be negative because it will retard the motion, it will decelerate, it will slow it down. Okay, so that. So here G will be negative. Okay, so here describing the motion of the ball means to find the velocity after each second. So here the appropriate equation will be V is equal to U plus AT, this, because these are the only parameters which we know. So for this, for the upward journey against gravity, the equation will be V is equal to U minus GT, because gravity is acting downwards, initial velocity is directed upwards, so it will be opposing the motion. So this. Okay, so final velocity, let's say after 1 second. Okay, 1 second, at 1 second, this will be equal to initial velocity 29.4 minus 9.8 into 1. Okay, so that will be equal to 19.6 meters per second, velocity after 1 second. Then velocity at 2 seconds means after 2 seconds has passed, so it will be again U minus GT, it will be 29.4 minus 9.8 into 2. Okay, so it is 29.4 minus 19.6, which is equal to 9.8 meters per second. Okay, 9.8 meters per second. Then velocity after 3 seconds, it will be 29.4 initial velocity minus G 9.8 into 3, which is the time, that is equal to 29.4 minus, here it will be 29.4. So here finally after 3 seconds it comes to rest. After 3 seconds it comes to rest. The ball comes to rest. Okay, so here if we draw the whole thing, it will be something like this. Ball started with an initial velocity of 29.4 meters per second. Then it went upwards. Here after 1 second, okay, after 1 second the velocity was 19.6 meters per second. Then it went further upwards. Then after 1 second, that is after 2 seconds, its velocity is 9.8 meters per second, directed upwards. So let us bring it a bit down so that we have some space. Okay, then again after 1 second it finally came to rest. Totally after 3 seconds it comes to rest. 0 meters per second. This is the position where it comes to rest. Then again from this position it will start its downward journey. Okay, it will start its downward journey. So let us trace that. So from here the ball will start its downward journey, 0 meter per second. In this case, the velocity with which it will move, it will be downwards. Okay, here acceleration is also acting downwards, acceleration due to gravity. In this case, for the downward journey, the initial velocity is 0 meter per second. Acceleration is plus 9.8 meters per second square acting downwards. So the equation of motion which is applicable for the downward journey is u plus gt, which is the final velocity at each time instant. So again, here we'll also trace the whole downward journey. Let's say this instant where the velocity becomes 0, let's say that is 0 second, t equals to 0. From then, after 1 second, it is u plus gt, that is 0 plus 9.8 into 1, which is equal to 9.8 meters per second. Okay, then after 2 seconds it is 0 plus 9.8 into 2. Simply we are putting this formula. In place of t we are putting the different time instants. G is 9.8 plus, because it is going downwards, the velocity, the motion of the ball is downwards. Acceleration is also downwards, acceleration due to gravity. So acceleration is taken as positive, because in this case acceleration due to gravity is supporting the motion. It is causing it to accelerate. That's why see, the velocity is increasing. So in this case it will be 19.6 meters per second. Then after 3 seconds it is 0 plus 9.8 into 3, which is 29.4 meters per second. So again, if you see the downward journey, this is the point where the velocity was 0 meters per second. After 1 second, the velocity of the ball is 9.8 meters per second after 1 second. Then again, after further 1 second, it is 19.6 meters per second. Okay, 19.6 meters per second, and then further it is 29.4 29.4 meters per second after 1 second. So if you compare this with this, the upward journey with the downward journey, if we bring this here, okay, this is the upward journey and this is the downward journey. Okay, let us this is the downward journey. So you see the velocities at each respective identical time instance, it is equal. Okay, this is the upward journey, this is the downward journey. Here, this is the upward, this is the downward. So the velocity at each respective time instance, identical positions, it is the same. Here it is 29.4, here it is also 29.4. Here it is 19.6 meters per second, here it is 19.6 meters per second. Here it is 9.8, here it is also 9.8. Here it is 0, here it is 0. Okay, so there are certain important conclusions about a freely falling body under the influence of gravity. So the time taken for the upward journey, okay, these are the conclusions which are very important for freely falling body. The time taken for upward journey is the same as the time taken for the downward journey. Okay, this is the first important conclusion, which is very important. So here the time taken for upward journey is 1 plus 1 plus 1, 3 seconds, and the time taken for downward journey is also 1 plus 1 plus 1, 3 seconds to arrive at the same point. Let's say this is ground. Okay, this is the ground from where the ball was thrown with certain initial velocity 29.4. It took 3 seconds to come to rest against gravity. Then from that point it took 3 seconds to come to the ground to exactly the same point from where it was thrown, at the same level. And the velocities at identical time instants are the same. So here another important conclusion is the magnitude of the velocity. Okay, here I am telling that only magnitude, not direction. Magnitude of velocity at identical or same time instance is the same, which I was saying. Here at the same identical position it is 29.4 meter per second upwards, and the same position it is 29.4 meter per second downwards. It is downwards. These are all downwards. The velocity is downwards. Okay. Here it is 19.6 meters per second upwards during the upward journey. Here it is 19.6 meter per second downwards. Here it is 9.8 meter per second upwards. Here it is 9.8 meter per second downwards. Here it is 0. Here it is 0. Rest. From here it starts the downward journey, and during the upward journey here it comes to rest. Then another important conclusion is the velocity with which the ball was thrown upwards, it comes down with the same velocity. It was thrown upwards with a velocity of 29.4 meter per second, okay, and it came down with the same velocity, that is 29.4 meter per second downwards. Okay, the ball was thrown upwards with 29.4 meter per second. It came downwards with a velocity of 29.4 meters per second. So the important conclusion is the velocity with which the ball is thrown upwards it comes down with the same velocity. And another important point is that both the upward and downward journey, okay, both the upward and downward journey, it takes along the same path. Okay, it takes along the same, exactly the same path. It's like this. Okay, first the ball, it started with a certain initial velocity. It started with certain initial velocity, okay, 29.4, 19.6, 9.8, then finally 0 meter per second. Then it starts along the same path downwards. This is the upward journey path. Then again it starts along the same path downwards, exactly the same path downwards. Okay, here just to make you clear, clear to you the upward and downward journey, I took a bit of a gap between both, but actually it takes along the same identical straight line path. The same path which it took during the upward journey, it takes the same path, identical path, straight line path, exactly the same path during the downward journey, and the velocities at the respective time instants are the same. The velocity with which it is thrown upwards, it comes down in the same, with the same velocity at the same point, and the time taken for the upward journey is the same as the time taken for the downward journey. So these are the important conclusions of motion under gravity. The body takes the same identical straight line path during both upward and downward journey. Okay, this is the fourth conclusion. So these are the four important conclusions which we will be using when we are solving questions related to motion under gravity. So always, this question is very important. It's a very good question to understand the important points related to motion under gravity. Okay.